Hi, I'm Chen Chen from the Network-Based Computing Lab at The Ohio State University. Today I'll be talking about our IAC 2026 paper on multi-rare aware hierarchical MPI reduced scatter and Allgather. Our work targets large-scale deep learning and HPC. So we know that training frameworks like FSDP shard model parameters across GPUs, and they code reduce scatter and Allgather on every single step. Meanwhile, top HPC nodes now come with multiple GPUs and NICs. For example, 4 GPUs and 4 NICs on each node. The problem is, generic MPI treats this whole cluster as one flat pool. It doesn't know which NIC sits next to which GPU, and it runs the intra and the internal phases one after the other. On top of that, it often lacks GPU-based designs and falls back to staging data through host memory on the CPU. So communication ends up being the bottleneck, and all that parallel bandwidth just go to waste. We fix this with 3 ideas. First, a real aligned hierarchy. Every GPU talks only through its closest NIC. So GPUs with the same local rank across nodes form their own independent layer, and the layer doesn't step on each other. Second, zero-copy GPU kernels. They place data directly where it needs to end up using IPC and GPU-direct RDMA. No host staging, no repaking, nothing extra. And third, couple pipelining. We flow the local broadcast into each step of the network ring, so while one chunk is going over the wire, the previous one is already being shared with the local GPUs. All of this comes together at one framework, a drop-in replacement for MPI-reduced scatter and Allgather, working on both NVIDIA and AMD GPUs. We tested on 3 systems, Delta AI, Mail Nostrum 5, and Cosmos. On the left, we show reduced scatter latency on 128 AMD GPUs. We are 2.7 times faster than Rico at 64 MB, and 4.1 times faster than NVIDIA Plus at 256 MB. On the right, we show application-level results of end-to-end NanoGPT FSDP chaining with GPT-2 models on 256 H100 GPUs. We are up to 2.2 times faster than baseline OpenMPI, and even 7% ahead of the vendor-optimized Nickel stack. So to wrap things up, putting all 3 pieces together, multi-rare awareness, zero-copy kernels, and pipelining designs, we get up to 7.3 times on reduced scatter, 8.9 times on Allgather, and 2.2 times on the full FSDP chaining. And the nice thing is, it just works on both NVIDIA and AMD GPUs over InfiniBand and Slingshot. So if you are interested in our designs, feel free to drop us an email or come to say hi during the conference. Thank you for watching.